Hey Honors Chemistry, I wanted to do another video on naming and writing formula including transition metals. So, this video will not include compounds that have polyatomic ions in them. I want to make sure that we get this gist or idea of how to write the formulas and how to name compounds including transition metals, okay? So, first things first, if I'm given the name, there's several pieces of information that's given to me here, okay? Several pieces of information. I have cobalt-3 chloride. Now, first step, as you saw in a previous video, is I gotta write the symbols. So if I look on the periodic table, I'm gonna look for cobalt. Cobalt is CO. Okay, so cobalt is CO. I'm gonna write that, CO. And chloride, if I know the element that it comes from, chloride comes from chlorine, which is Cl. It says chlorine here, but when I name it in a compound, it becomes chloride. So I'm gonna write Cl. Okay, and then now I gotta figure out the charges. So step one was symbols. Step two is charges. Okay, now in the name it says cobalt-3. What does the Roman numeral represent? So the Roman numeral represents the charge. Okay? So what is the charge on cobalt? 3+. All right? And it's the charge for the transition metal only. Okay, so cobalt-3, the 3 corresponds to the cobalt. Chloride, if I don't know which charge off the top of my head, I want to find chlorine again. Chlorine is over here. And elements in group 7 here form a -1 charge. Okay, so I'm going to write -1. Okay, now, I like using this method, but what I want to look at is I want to figure out how many of each ion I need that the sum of the charges equals 0. So I like to use my least common multiple idea here. LCM is least common multiple. And it's going to be between 3 and 1. And between 3 and 1, it is 3. All right, so I want them both to get to 3. Well, CO is already at 3+. It's already at 3. What do I got to do to chloride, or Cl, to get to 3? Well, I have to multiply that by 3. Now, some of you could do this off the top of your head, and you would know that you need 3 chlorides, but I like showing the work. All right, so I have +3 here, and -1, -1, -1 is -3. If I add +3 to -3, this equals 0. So this is correct. I need 1 cobalt for 3 chlorides. So how do I write a formula that has 1 cobalt and 3 chlorides? Well, it'd be COCl3. This would be cobalt chloride. Now, as the cheat code, or the cheat with the crisscross method, you could do CO3+ and Cl-1. If I want to do the cheat crisscross method over here, you're going to arrive at the same answer. I'm going to take the 3 and crisscross it down. I'm going to take the 1 and crisscross it down. So I'll get CO1, right? Remember, I do not write the charge. I'm not writing positive and negative. I'm just putting the number. So not the charge, just the number. Just the number, kind of like a counting number. All right, you don't count with negatives, right? So I'm going to put the 3 over by the Cl and the 1 over by the CO. So this becomes, the 3 went over by the Cl, I got Cl3. The 1 went over by the CO, I got CO1. And then we don't write 1s in formulas, so this becomes COCl3. And is the same answer. Okay? So, step 3, after finding the charges, I like to do least common multiple. Step 4 becomes how many of each ion. And then step 5 is finally writing the charge. I'm sorry, writing the compound, write the formula. And that's what we did. So to recap that, first we wrote the symbols, then we figured out the charges. I remember the Roman numeral was the charge for my cobalt. The -1 for the chloride came from the periodic table here, right? So chloride is here. Then I find my least common multiple. How many of each ion do I need? And I figured out I needed 1 of these and 3 of these. And then I write the formula. I needed 3 of these, 1 of those, and that's how I get that. And doing another example, let's try and figure out the name now. Remember, I said in this practice, I'm not doing polyatomic ions. So let's try and name each one using the periodic table, and then we can figure out the charge. So Cu, according to the periodic table right here, that's copper. So that's copper. As, according to the periodic table, that's arsenic. I'm going to write it as arsenic first. All right, and remember, this is going to be my cation, and this is going to be my anion. And what do I usually change the ending to my anions names? I need the IDE. So arsenic becomes arsenide. All right, so I have arsenide. I'm going to name that as arsenide later. And now I have copper, but I got to figure out the charge. Now remember, for transition metals, copper is a transition metal. Transition metal. All right, copper is a transition metal, so I need Roman numerals. But do I know the charge off the bat right now? No, I gotta figure it out. There are 2 arsenics in here and 3 coppers. Okay? And I know that the sum of their charges equals 0. But I don't know what copper is right yet, but I do know the charge that arsenic forms. If I look on the periodic table, arsenic is here. It forms -3 charges. Arsenic forms -3 charges. So how many arsenics are in here? 2 of them. So each of those arsenics have a -3 charge. That means the total charge on both those arsenics is -6. What number plus -6 gives me 0? And remember, we want the sum of the charges to equal 0. And so you're probably already telling me that this has got to be +6. Okay? Now, where does this +6 come from? It comes from 3 coppers. So what must the charge on each of those coppers then be? Well, if I want to distribute that +6 evenly among the 3 coppers, that must mean +2, +2, and +2. They are each positively 2 charged. Okay? Now, if each copper is positively 2 charged, that must be the charge of the copper in this compound, and now I have to name it as such. If I want to name copper 2+, this is copper. What Roman numeral do I use? 2. And then how do I name arsenic? We said arsenide. Copper 2 arsenide. And this is one of your examples from your homework. So Cu3As2 is equal to copper 2 arsenide. So I'm hoping this video was helpful. This was another crash course on naming and writing formulas involving transition metals. Let me know if you still have any concerns or problems with naming compounds involving transition metals.